So for these ones over here, right, I said that there was a third type of question they can ask you, and it's these questions here. What were we doing? What does this number represent again? These random decimals that we're finding. Areas under a curve, right? But they might ask you to go the other way, right? They may ask you, okay, instead of finding the area under the curve, can you find for me the sort of z-score, so to speak, right? So when I'm asking about the z-score here, what's the decimal value that's going to give me the median, right? Now the median is an interesting example because, well, to find the median, you actually don't need to do any calculations. Yeah, it's just what's in the middle there, right? Because remember, the median in a standard normal distribution is the same as the average, the same as the peak. It's everything on that side there. So a median contains 50% of the data. So what's the median? Well, the median is just 0, right? So the median is 0. So for these ones, I'm not asking for the area under the curve anymore. They're essentially giving you the area of the curve, and they want you to find what score is going to give you that value, right? So lower quartile, just have in the back of your mind, the answer isn't this, but what does the lower quartile mean? It's like the 25% of the data at the end, right? And how we've been writing these areas, we've been writing them as percentages. So basically you're looking for 0.25 here. Now, one issue is that on your tables actually, you won't be able to find 0.25 exactly, but you just kind of want to find what's closest to it. So if we look along here, yeah, very accurate, right? Now, obviously, if we were doing this using, you could use integration to actually do these, but these are the types of questions that they ask you. They expect you to be able to use the table, right? So, where does it look like 25% is roughly? Let's have a look. Let's get rid of some of these. Let's have a look here. 25, what was that, James?
6, 7.
Oh, wait, I'm on the wrong one. Yeah, I haven't gone far. There we go. So 0.25 looks like it's roughly here. Now, I guess what you might want to do is, you've got kind of two options here, 6, 7 and 6, 8. I guess pick the one that's closest is my tip. So this one is 0.2514 is 0.014 away, and this one's 0.0017 away, or whatever. So probably pick this one. I'm guessing that's 7, is that right, James?
Yeah.
Yeah, so 0.67. Does that kind of make sense what you're doing? So instead of using the columns and rows now, what you're doing is you're looking for the area under the curve, which is going to match the criteria you're looking for. So we want where did we go? So we end up with 0.2514 is the closest, and when you go up to, that's negative 0.6, and it goes up to 0.07, right? So negative 0.67. That should not be a decimal, it's just a full stop.
I have no idea what you just did.
Yeah? Okay, I'll explain it again, yeah? I'll explain again with the next one, right? So, Luan, what we're trying to do is, this time I don't want to know I'm not using the columns and rows to do it in the same way. This time I'm asking the opposite question, right? So the opposite question is, what's the z-score that gives me that area? Does that make sense? So I'm saying I don't care about the area under the curve anymore. They're kind of giving you the area under the curve, right? So, for example, the upper quartile, that word quartile, what does that mean again? Do you remember?
Like 0.75?
Right, so the upper quartile is 0.75, it's the quarters, right? So 0.75, right? And basically, you want to know, okay, sorry, that's not 0.75. This is 0.75 here. So the area is 0.75, and you want to know what value here is going to give you that. Does that make sense, what we're doing? Right? So instead of saying, find the area under the curve, which is what we're doing over here, this time you're saying, okay, well, the area under the curve is 0.75. What's the value that I need to get that? Does that make sense?
Like you're finding 0.5 on the table.
Yeah, right. And so remember how before we were actually just plugging it in on the columns and rows? But now they're giving you the answer. Now they're giving you 0.75, right?
Yeah.
And then you need to find that number in this wall of text and then kind of go backwards and find what... Sorry?
That's a trick.
It is. It's a bit difficult, yeah. That's why it's like the standard way of doing it, because in Mathematics Standard, they don't have integration. So they obviously can't do it the way that we might approach it, right? So that's their skill. This is what I said about, it's an easier skill in some sense, but again, if you don't practice it, if you're not familiar with what you have to do, then that's why it's going to be something you might get wrong, yeah.
What's decile?
The 6th decile, so decile is like tenths. So what do you reckon that value would be that we're looking for? Yeah, 60% or 0.6, right? So you're looking for that in the table, yeah? Does that make sense, Lon?
Yeah.
So 0.75, can you find that one for me?
0.75.
Yeah.
So it shouldn't be.
Oh, good question. Yeah, good observation actually. So what you might notice is because we already found the lower quartile, because of the symmetry of the normal distribution, they'll probably be the same magnitude, but just with, instead of negative, it will be positive, right? Because if you're going to the lower quartile, which was negative 0.67, then due to symmetry, you'll probably have a similar value. So that's actually a good thing you can do.
It's the same. 68.
6 area, which one's it closer to is the question. So that's like, again, it's not like entirely accurate because we can't do this precisely, right? But if I'm looking for 275, there's this option here, so 7486, and then there's, right, so which one is closer then?
6, 7.
Yeah, 6, 7, right. So because that one's a bit further out, that's like 17 or whatever, 17th. So 0.67 looks like it's the closest one. Yep. Yeah, that's exactly right. Yeah, so you might be able to use that property. Yeah, that's another thing you could just use. Yeah. You're making a joke there, Eva. Eva can do the next one because she's so funny. So 0.84, what are we looking? Yeah, you reckon? So let's see. 0.84. So 0.99 looks like 0.389. So we're what? 11 points away, and this one's 13 points away. So yeah, 0.99 looks like it's the closest there. Is it boring? Well, luckily you're not doing mathematics standard because their whole topic is like this. So how fortunate are you guys to have learnt about integration and density functions and those cool little equations? Well, actually, in the beginning, this is what I did. I actually taught you the concept of a z-score and stuff. And I was like, this is kind of how mathematics standard would approach it. And then afterwards, I introduced the concept of how that relates to integration areas on the curve. We're just kind of going through this a bit more thoroughly now. Yeah, so good question. Yeah. Did you end up getting 6 decile? What was that? Let's have a look. So 0.6. So what's closest to 0.6 here? 5987 is pretty close. So yeah, that's the pretty closest one. So 0.25 there. Perfect. That's it. Any questions? No? Easy.